The isotope we have chosen is nickel-63. Nickel-63 is an isotope of nickel and has a half-life of approximately 100 years. It undergoes beta decay to form its daughter nuclei, copper-63. Nickel-63 is commonly found and collected during neutron capture on enriched nickel-62, and it is also created in nuclear generators. Nickel-63 is most commonly used for detecting explosive gases. It is used in two systems, the electron capture detector, ECD, and the ion mobility spectrometry, IMS. These two systems work very similarly, but one is used to find explosives in the air, and one is used to find explosives underground. Scientists and whoever have a permit issued by the USDA can use these systems. The IMS machines test for explosives or other compounds of interest, which may be present in the air in the form of vapor or airborne particulate matter. In a typical IMS, air is drawn into the ionization and reaction region, as shown on the diagram. Once the air enters the ionization region, it will react with the metal that is covered in a nickel-63 coil, which will either create positive or negative electrons. In the case of explosives, negative electrons will be created. The air then travels through the drift region, which will tell you if there is an explosive as well as how far away it is. This is measured by the time it takes for the electron to get through the drift region. The ECD work very similarly as the IMS, but in opposite terrain. The ECD machines work by drawing in vapor from the ground through the column as shown on the graph. Then the electrons combine with a carrier gas, which is usually nitrogen. The nickel-63 emits electrons which collide with the carrier gas, which forms a cloud of free electrons. At the end of the top chamber, the current is measured, and that will tell you if there's a bomb nearby.
The benefits to this radioisotope is that it is incredibly safe. You can only get radiation poisoning if you ingest large amounts. It doesn't change off the same decay for its whole decay period, and that the half-life is a long amount of time, so you can use it for longer. The cons are the fact that it is not naturally occurring, and it also is very expensive to make.
The machines that nickel-63 is used in are very effective, long-lasting, and pose no threat to the environment. Nickel-63 on its own is also not dangerous unless you ingest large amounts of it. Because of these reasons, we believe that nickel-63 should continue to be used to detect explosives because it causes no harm to people or the environment.